Hey gang, we are ready for 1-4, which I think you'll enjoy because it's familiar territory. Not sure why college algebra chooses to do circles and then circle back to lines, but this is the way we do it. Okay, let's go for all the different equations of a line. I know in Algebra 2 we stressed slope-intercept, okay? But we're going to use point slope a lot in calculus. So those of you that will be going into calculus, you want to make sure you have a good understanding of that. Let's just look at this line first of all. We're talking about a line that goes through the point 2, 3 and -6, -1. Okay, I can draw the line. They're not asking me to draw the line. They're asking me for the equation of the line in different forms. Okay, so for every line, we usually live in the slope-intercept world in Algebra 2, y equals mx plus b. Love it. It's my favorite form, right? Because I can see the slope, I can see the y-intercept. If I look at this and I remember stuff about slope, I know that I can rise. What would that be? I was at -1. I'm going up to the rise 4, run 8. Rise 4, run 8. And it looks to me like I'm going through the y-axis at 2. So that would be y equals a half x plus 2. That's what I think it might be, just from eyeballing this and making a rough sketch. Okay? Well, obviously, we don't want to eyeball and make a rough sketch. We want the exact equation. So if I don't eyeball and make a rough sketch, then I'm going to find the slope by using the slope formula, which is subtract the y's divided by get what you get when you subtract the x's. So that's -4 over -8. Oh, it is 1/2. Great. Y equals 1/2 x plus something. I'm not sure what the y-intercept is, so I do know a couple xy points. I'm going to use them. Okay, so I have y equals mx plus b. Y equals a half. I know that for sure. A half x plus b. I'm going to pick the 0.23 because I don't feel like dealing with negatives. I'm going to put 3 in for the y coordinate. I'm going to put 2 in for the x coordinate. And I'm going to get 3 equals 1 plus b, because half of 2 is 1. I'll subtract 1, and now I see that b equals 2. Fantastic. Now I know what I kind of guessed from the beginning, that the equation is y equals 1/2 x plus 2. Okay? And I could have used -6, -1, putting -1 in for x, y, blah, 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 and -6 in for x, and I still would have gotten a b of 2. Okay, I just chose 2, 3 because I didn't feel like dealing with the negatives. All right. Point slope, guys, I know we don't use it tons in Algebra 2. It's y minus any y coordinate on the line equals the slope times x minus any x coordinate on the line. Okay, I mean, you have to pick one point. X1, Y1 is just one of the points on this line. Okay, so I still would have had to find the slope the same way I found the slope over here by subtracting the y's. I'll go the other way just to show you get the same thing. And then subtract the x's. That would have given me +4 over +8, which is a half. I still would have had to do that. Okay, but now what I do is I pick one of the points. I'll pick 2, 3, and I say y minus the y coordinate equals slope times x minus the x coordinate. And sometimes we can stop right there. That's point slope form. It's another form just like this one. Okay, it's just when I look at this, instead of knowing the slope and the y-intercept, I know the slope and a point. Okay, I can say, oh, the slope's a half, and it goes through the point 2, 3. Here I say the slope's a half, and it goes through the point 0, 2. Okay, I know the y-intercept from there. Two different forms. Notice what happens if I decide to go further with this and distribute the half through and add 3 to the other side. I get y equals a half x plus 2. I mean, it's the same line. All right, it's just a different form. Y minus the y coordinate equals slope times x minus the x coordinate. Okay? Some of you might be like, well, what if I would have picked, -1, -6, -1? Well, then you would have gone y minus the y coordinate equals 1/2 slope times x minus the x coordinate. So you'd have y plus 1 equals 1/2 x plus 6. If you distribute the half through, half x, what's half of 6? 3. Subtract 1. You get y equals 1/2 x plus 2. I mean, it's still the same line. Okay? No matter what point you pick on this you pick an infinite number of points. These are both the equation of the line, this red line right here. Okay, point slope, slope intercept. Standard form, some number x plus the number y equals another number. It doesn't really give you any of the forms. Oh, I think I had, I'm sorry. I don't know why I chicken scratched that graph when I really wanted to graph it over here. What was it? -6, -1, and 2, 3. Okay, so here's our graph. And I want to get it into this form. I have y equals, I know it's y equals 1/2 x plus 2, but that's not the form I want. Standard form has x and y on the left-hand side, so I'm going to have to subtract half x over there. Okay, and then in standard form, in true standard form, a, b, and c are integers. And a is positive, guys, okay? A is greater than or equal to 0. Okay? Is that all right? So I'm looking at this and I'm like, well, -1/2 is not a fraction. So if this happens, I'm going to multiply everything by the denominator of 2. That gives me -1x plus 2y equals 4. And a is supposed to be positive. So now I'm going to multiply everything by -1. And my final answer will be positive x minus 2y equals -4. X minus 2y equals -4 is standard form. Okay, let's look at this. A lot of times I like to think as like intercept form. Okay, because I can see the intercepts from here a little bit better. In other words, if I put 0 in for x, imagine that's gone. Then I just have -2y equals -4. Divide by -2, I know y is 2. If I put 0 in for y, imagine this term gone. I just get x equals -4. So this is a nice form for noticing that the x-intercept is -4 and the y-intercept is 2. Okay, it gives me those 2 points quicker. And a lot of times in real-life problems, those are the 2 points we want. Okay? We're going to use this graph to solve the equation 0 equals 1/2 x plus 2. So in other words, I have the equation y equals 1/2 x plus 2. I want to know when 0 equals 1/2 x plus 2. So all I'm looking for is when y is 0. Isn't that right here? So using the graph, I think the answer is -4. It says use the graph. I understand I could use algebra. I could have subtracted 2 from each side and then multiplied each side by 2 to get -4 equals x. Okay, I get that. But in college algebra, we really stress using the graph of any equation. Okay, realize, guys, we're going to do quadratics, we're going to do polynomials, we're going to do exponential functions, we're going to do radical functions, we're going to do rational exponent functions, we're going to do logarithmic functions. Any function we have, right now we're using a linear one. And when we are saying use the graph to solve the problem, we mean graph y equals whatever this is. So in this case, it was y equals 1/2 x plus 2, and see where it crosses the x-axis. That's what it is when we set something equal to 0. Okay? It's something that we stress more in college algebra than we do in algebra 2. Okay? So here we have the same thing. Write the equation in line that goes through this. Find the x and y intercepts. And write the equation in slope-intercept form and standard form. You can't see the rest of that, but that's what that says. Okay. I can't move it. And standard form. I'll move that over later. Okay, so I'm going to use point slope. Oh, I love when I have a point that doesn't have any negatives. I'm going to say y minus 1 equals, oopsies, I forgot to find the slope. So I'm going to subtract my y's, 5 minus 1, subtract my x's, -3 minus 2, 4 over, what is that, -6. So I think the slope is -2/3 if I reduce it. Might as well have graphed it a while. -3, 5, and 2, 1. Okay, so there's my graph. Oh, good job, Kel. Jeez, sorry about that. If I click on this little, so annoying. Sorry. That'll give you a little bit to get caught up there. Go ahead and plot the points to 1, -3, 1, 2, 5. I was trying. No, I can't. Okay. Hopefully you graphed it. Maybe use a ruler. Get it nice and straight. Not like me. Do as I say, not as I do, right? All right. So my equation of the line then is y minus 1 equals the slope times x minus 2. So they want me to have it in slope-intercept form, so I'm going to distribute the -2/3 x. Okay, -2/3 x. -2/3 times -2 is +4/3. I'm going to add 1. Okay, well, adding 1, I'm going to think of 1 as 3/3. So I get y equals -2/3 x plus 7/3. Great, that's slope-intercept form, done. Standard form, well, not too terrible. I'm just going to add the 2/3 x over here with the y. That first step's not bad. You just add the x term or subtract, whatever you have to do to get the x term to the other side. Then I remember that all the numbers have to be not fractions. They have to be integers, and the first term has to be positive, which it is. So I really just have to multiply everything by 3 yet. Yay. There's standard, slope, intercept, and I used point slope to get me there. Okay? I need to find the x and y intercepts yet, which I will do on the next video.